So I would like to share with you a class that I've been teaching for quite some time, and the title of my talk is "Come for the Pseudoscience, Stay for the Science." And I just kind of want to take an opportunity to share some of the fun I get to have when I teach this class every semester. The class is called Natural Science 4, whatever that might mean, but we call it Science and Nonsense. And it has a little bit of a reputation on the campus, so students know they're going to learn about UFOs and things like that. So that's kind of what draws them in. I've been teaching this particular class since 2000 and constantly tweaking it, constantly come up with some strategies. I always have in my structure of my class, the final exam has a little reflection essay where I ask them to kind of, well, have your mind changed about anything? And so this was like a little informal way of measuring outcomes that I had been doing for some time. And here's 233 students, and you can see that a lot of people have changed their mind about chiropractic manipulation. It might be that's the last thing I cover in the class, and that's why it kind of sticks with them. But you can see that a lot of folks have talked quite a bit or changed their mind about a number of topics. Now, this critical thinking class is a bit unique on the campus. I am at Fresno State. It's one of 20 plus CSU system universities in the California CSU system. Maybe you're not familiar with that, but there's a UC system that has our doctoral degrees. And then we have this middle ground where we serve 450,000 students. More than 20,000 on our campus alone at Fresno State. And in 1990s, the CSU system at the highest levels said that every student must take a critical thinking class before they can graduate. Now, unfortunately, the problem is they didn't really define what critical thinking was, as was a problem, as was stated earlier. So things like determining if it's inductive logic or deductive logic, being able to determine fact from opinion, and things like that. But those are all very philosophical. They're not very diligent or rigorous outcomes. And so we are thinking of a new outcome here. We want critical thinking to change people's minds so it reduces false belief. And so coming back from one of these skeptical conferences, Katie and I brainstormed maybe an instrument to measure an outcome. And so, as stated earlier in Dr. Guz's talk, it's kind of hard. We can measure the skills. You can measure some of the skills of critical thinking, but how do you know if you're getting them to have the ability to apply it, and then kind of the frame of mind to always have that in the front of your mind? So we thought, well, the best way to know if they're actually applying these critical thinking skills is if they're reducing belief in false beliefs, or what we call epistemically unwarranted beliefs. So we created this survey, and it has basically a Likert scale. And so we actually published this result, and I'd just like to give you a couple slides, the highlights. And so one of our main outcomes is, again, when students graduate, if they reject false beliefs, we have been successful. So one thing that our instrument measures is pre and post, and we find comparing national polls with basically our study sample of 806 students, we find that at least coming into the program, and these are mostly students that have been there, they're at least a sophomore, if not a junior or a senior. So this is, somewhere in the mid of their college career, and you'll notice that they believe in a lot of these epistemically unwarranted beliefs just as much as the general public. And this is disconcerting, right? Obviously, they're learning professional aspects of their career choices, things like that. Our general education is informing them about things, and yet they seem to just leave the university with these false beliefs. And I feel we are failing these students. And that's kind of what I'm trying to promote here, is to get critical thinking classes that not only teach the critical thinking skills that are really well defined in a lot of critical thinking books that you can get out there, but let's apply them directly to these epistemically unwarranted beliefs. So we found what everybody else has found. These are quite a few studies that kind of show this effect, that students are leaving higher education, unfortunately, carrying a lot of these false beliefs. So we had 806 subjects. We were trying to test a couple of ideas. We had basically this pseudoscience critical thinking class, that's what we're calling our intervention class. I taught a couple sections of it. We also wanted to test Carl Sagan's famous statement that pseudoscience is believed in proportion how little science is understood. So we wanted to test that. So we thought, let's see a pre and post from somebody taking a research methods class in psychology. We had a number of sections, number of different teachers on that. And then we had just some basically GE courses that nominally didn't have that much relationship to critical thinking, which is sad that there's any course that doesn't have a relationship to critical thinking, but you can think of some. And basically, we also had a pretty long inventory. So we used a factor analysis to kind of group these answers. And we found that the factor analysis really found some really nice groups here. One we call extraordinary life forms. That would be like Bigfoot and UFOs. For some reason, students kind of correlate with those beliefs. Conspiracy theories were a thing on its own. So those were the categories. And here's our results. So you can see in the top corner here, we have basically the GE courses, completely flat pre and post. The lines are decrease or increase, as the case may be. Research methods group, you see mostly flat. Matter of fact, we didn't find anything significant, any significant effect size in the research methods classes. Pretty fascinating. But the intervention class really seemed to work, and it worked on almost every category. And so this gave us a lot of hope that this technique kind of works. We also can dichotomize it, and when we do that, we see that students believed on average of 13 items on the instrument pretest, at post-test 7 items. So we didn't eliminate them all, but we'll take that decrease, right? And so, so those are some of the results. And in essence, we also looked for all kinds of is there anything correlated with whether or not somebody changes their mind? And really, we found it worked on almost everybody. We had a religiosity scale that we measured it with. We looked at socioeconomic status. We looked at gender. We looked at all these things. The only thing that mattered a little bit was how well they performed academically. If they had better grades, they had more of a decrease. And that's the only result we could find in that matter. So it's kind of hopeful, though, that the techniques that we're using just seems to work for everybody, which is kind of nice. Let me just kind of take a point now I've never had this opportunity, so please indulge me, to kind of share with you some of what I do in that intervention class. So we call it Science and Nonsense. And I'd like to just pretend that you are coming to class on day 1. And one of the first interventions or activities I have is to think about astrology, right? Does anybody not know their sign? Anybody not know their sign? Okay, so you'll see in the middle of your table a stack of basically personality profiles according to your sun sign. If you could find one, if you flip them over, you'll see that there's different different ones. And just in case you didn't know your sign, here it is. Yeah, please find the one that matches your horoscope. Hopefully everyone's. You have yours, Rod? Right there, it's a blue right there. Good, okay. So please take a moment to read your personality profile. I did have one rule with my students, and I say, let's not talk about it until after we process it ourselves. Maybe you know this activity. If you do, please check out my presentation of it. But take a reading. How well, and I would like you to assess on your own, how well does it fit? Is it a complete miss, or is it amazingly accurate on a scale from 1 to 5? I'll let you just have a moment to read that while I get a glass of water. Well, how about you, Rod? Did it match? Where are you on that scale? 4.5? Okay, all right.
It's a good match.
So anybody got a 1 or a 2? A show of hands? How about a 3? Is it pretty good? Okay, 3s are good. How about 4s? We got some 4s and any 5s. Oh, so clearly astrology works, right? I mean, it's pretty astonishing. Now, this is the way I do it in class. I'll say, okay, everybody, please trade with somebody else that has a different color piece of paper and read theirs. So, just a show of hands, how many people have seen this activity before? Well, thank you for playing along. It is great fun. I'll just show you I use clickers in my classroom, so I saved some data a few years, and these are the usual scores I get, and these students had not seen this, of course. And they're always clustered around 4 or a little higher. This last one was an honors students class, so a few smart Alecs down there in the red bin giving it a 2. But this is a pretty effective first day activity. My students are just astonished. They're gasps when I have them trade the papers. They really do. They gasp and they're laughing, and it's just So if we're trying to kind of promote that disposition of a critical thinker, this might be one motivation, that you're fallible, right? That they are fallible, we're all fallible. And it kind of hits home like, oh, maybe I shouldn't be quite so certain, you know? Maybe it's this first step towards intellectual humility. It could be wrong. So everybody knows this affects subjective validation. So also, you know, some of my heroes, I'm a physicist. So Richard Feynman said, first principle of science, you must not fool yourself, and you are the easiest person to fool. So just kind of this nice little saying. And so this is a too small a font to read, but a handout that I give that kind of codifies some of the most important learning outcomes according to critical thinking textbooks. We have a section here, for instance, on evaluating the evidence, and here we're looking for pitfalls of human cognition and perception that can cloud our judgment, such as subjective validation, for instance. So I'll have them look at this, and we'll talk about subjective validation. I also have evaluate the reasoning, so that's the logic component, most famous fallacies. Notice, you've probably seen these taxonomies of fallacies, right? They're laundry list long. But what I've tried to really do in my teaching is to boil it down to a handful of the most prominent ones. If they can recognize those, they're going to cover like 90+% of what's thrown at them out there. You know, there's some esoteric ones, and we definitely go over those. I also have a section that's informed by my philosophy of science, which is characteristics of pseudoscience. I know there's no perfect demarcation criteria, but these are the red flags that further study are necessary. And I can share this with you in a little more detail. But what I'd like to do, instead of just going over that list, is to throw at you a few more ideas of what I use in the classroom and how I try to get my students motivated to think critically. So let's go science. I tell them about, 2 theories of the solar system. We go back pre-Copernicus, right? Let alone that there's flat earthers now. I mean, when I started teaching this class, flat earth really was not on the radar, but now here we are. But let's just talk about a geostationary person, right? A person that doesn't believe the sun, or believes the sun is the thing that's moving, not the earth. And that was a prevalent view for a long, long time. So I challenged them with this following question. You believe the earth rotates, and most people agree with that. I mean, occasional flat earther aside, right? The earth is rotating. But if I could ask you, that's a correct belief, by the way, but how do you, if you had to support that, if you had to give evidence for it, can you give me some evidence that the earth is rotating? Can anybody, I mean, no? It's challenging. So I do want to throw there that part of science and part of having background knowledge is really crucial. And so in this case, can anybody think of any kind of activity or experiment that could be performed that could demonstrate whether the earth is rotating or if the sun is going around the earth is stationary? Oh, do you know the Foucault pendulum? You guys ever been to one of these planetariums where they have this big pendulum swinging? What in the heck's that for, right? And it actually demonstrates that the earth is turning underneath the pendulum. It's kind of a fascinating thing, but pretty subtle, right? And you have to believe a lot about Newton's laws before that's a compelling argument that the earth is spinning. So this is to kind of put out there that scientific explanations are a bit challenging, and we accept it on authority, right? Our kindergarten teacher told us that, or maybe it's 3rd grade. I'm not sure where you learn about the planets anymore. But one thing I try to convince them is like, well, it is pretty amazing. Science has shown us that things are very strange. For instance, if you're just sitting on the equator, you're moving more than 1,000 miles an hour just due to the Earth's rotation. And I try to get more specific for my Fresno State students. At a latitude of 36.7 degrees, you're moving at roughly 831 miles an hour. Oh, sorry, I should put that in kilometers for this crowd, for part of this crowd. But nonetheless, it kind of instills that a lot of our foundational knowledge seems to be contrary to common sense as well. It's one of my favorite things to point out. So I have them come up with 3 or more things. They have to go out and search the web. This also gives me an opportunity to talk about information literacy a little bit, start off the bat of where are we going to trust our sources. They write this in and we compare and contrast where they got their information. But most importantly, one of the most fundamental demarcation criteria, as imperfect as it is falsification. And so how do we falsify one or the other? And a lot of students write down, well, obviously the earth is rotating because the sun rises and sets. And I'm going, well, that would also, if it was also true that the earth was stationary and the sun was moving, that was what it looked like. And they didn't, you'd be surprised how many students don't discern that there's some meaningful measurement that you can make to discern one from the other, but that's not one of them, right? So it's really an opportunity to discuss some of these options. So rotation of the earth, they get confused and think I want them to prove that the earth is orbiting the sun, but that's not it. So one thing that I do is very similar to Dr. Peschnik. There is, I do have them not exactly do debates, but they have to make a presentation. And they have to make a presentation on the following list of topics. We don't have time for 12. We usually have time for 10 of these. There's some selection. I ask them to select one of 3 of the list, and I try to put them in groups. The strategy is not to have them actually have a debate, but to make the very best case they can for the proponents and the critics of the theory. And this puts them up on stage. It seems like peers are a little more receptive to hearing things coming from them, but I always force the issue. I don't quite have the students that are willing to prepare as fast as yours are, so accountability is so important if you're going to use this strategy. I have them turn in their slides a week ahead of time with 2 opportunities to revise. And if I don't do that, then this just completely fizzles and it goes nowhere. But if you force their hand and they have to turn things ahead of time, then it goes quite well. And I still have a lot of stuff in my back pocket when they're done talking about these topics. So that's my strategy. Also, what I find is really important, at least in the way I've tried to do this, is that the order really matters. So critical thinking skills are learned in a cumulative fashion. We start teaching them to recognize cognitive biases, certain forms of logical fallacies. We also teach about the scientific method in this class, but we haven't really gotten there yet. So the first thing I start off with every time is ancient astronauts. It's like the lowest hanging fruit. You might think, well, shouldn't we talk about UFOs first and then see if they came in the past? But it turns out the ideas of von Däniken are so ridiculous, right? That this is really a perfect place to start. And so you might know of Chariots of the Gods. How many people are old enough to remember when that came out in the theater, right? That was amazing. And of course, it's perpetrated today by this guy and the History Channel. I think every single thing the History Channel offers has some alien involvement with that explanation, aliens. But here I would like to share with you a little philosophically. I think a really important component of any critical thinking is the law of parsimony, or the principle of parsimony. I shouldn't call it a law. So William Ockham, you guys are all familiar with William Ockham. But Occam's razor, I think, is really important, even though in the philosophical circles, especially science, philosophy of science, there's a lot of debate about how important is it. But I think for the critical thinker, it's really important. The translation that's, I think, from the Latin is plurality should not be posited without necessity. What does that mean? Well, I would interpret it this way. I would say, my definition that I want my students to use for Occam's razor is, all other things equal, the hypothesis with the fewest and least implausible assumptions is most likely the best description. This gets them into this frame of mind of doubt, questioning the assumptions. It's more of a framing and a way to approach a problem than it is a rule that tells us at the end what hypothesis is correct. So I think what's oversimplified, you often hear it, right? The simpler theory is the better one. That is, I think, really problematic. Quantum mechanics is our absolutely parsimonious theory of physics, and yet nobody would say it's simple, right? Nobody would say. So I always like to say the way of thinking of it is the fewest far-fetched assumptions. So one strategy I use is to use the ancient astronauts. So a lovely Nova from like the 1980s has this kind of setup where they interview archaeologist Joanne Van Tilburg, and she says, oh, hypothesis is that they were pulled on wood rollers. So let's examine 2 theories. Erich von Däniken, extraterrestrial visitors must have helped, and we have Joanne Van Tilburg pulled on wood rollers. So how do we analyze these 2 things? Well, I set them up and I asked them, and this is where I would actually have their input, and we would take at least 15, 20 minutes to parse this out. But if Erich von Däniken is correct, what assumptions must we make? And one is that extraterrestrials are out there, right? But that's, of course, not necessarily, most scientists might say, oh, the likelihood of extraterrestrials is out there. What else must be true? Well, they have to travel to Earth, right? Okay, that's pretty problematic because they have to be able to travel between stars. And they actually kind of come up with this themselves, right? Can travel faster than light. Now that's where I have to interject a little bit and go, well, that's really problematic with our best theories of science right now. So that's starting to get really, I mean, it happens on Star Trek and Star Wars all the time, but in reality, that really is a problem. They can move many-ton statues with anti-gravity beams. Well, if you've already made 3 radical assumptions, what's another one, right? My favorite, though, is to also impose a little bit of like motive, that they would come all this way to make giant depictions of men on a lonely island, right? Why? Why? So on the other side, wood was plentiful on the island. Oh, we can point to that. They actually have trash piles. You know, we look at their dump sites. The people knew how to make rope. enough strong people for labor. All of these, there's archaeological evidence for. Clever in their methods, managed to hide the traces of the moving. And so that's kind of a nice one that gets the opportunity, and I always put that one kind of first so we can have that conversation about making assumptions. Also, Occam's razor then is one of those things that I emphasize in kind of my short form of the learning outcomes, and it's part of hypothesis evaluation. So it's always there to get them to kind of get down that path of alternative hypothesis. Speaking of alternative hypothesis, check out this guy. His name is Wally Walton, and he's building Stonehenge in his Flint, Michigan backyard. Have you guys seen this? It's absolutely fantastic.
This man swears he's cracked. He's building his own Stonehenge in his Flint, Michigan backyard to prove it. Wally Wallington's not a scientist, but he knows a thing or two about moving rocks.
That's a 300-pound block. This is a 1,600-pound block. Not too difficult.
He's a retired construction worker whose passion is moving heavy items.
Yes, that's his passion. And it's fantastic. So I recommend that whole thing. I'll send a link to that. It's still on YouTube. This is from about 10 years ago. And he actually stands up a 16-ton obelisk under his own power with no use of, just stacking rocks and using balance in a teeter-totter fashion. It's absolutely phenomenal. So we talk about visitors now. Let's go to UFOs. That's the next thing on my list. A couple of things I love to is that first thing I do is, before we even go into UFOs, memory. Mostly UFOs are testimonial, and they're so I have them watch the famous gorilla video. Spoiler, just saying gorilla video, right? But I think everybody's seen it here, right? Most of my students haven't seen it. It used to be very popular to show in psychology classes. Not so much anymore, so most of my students have not seen this, and they're astonished. We also, have them watch, and we talk about Elizabeth Loftus. We also talk about the Innocence Project and how imperfect witness testimony can be and how careful we have to be about that type of stuff. So this is kind of the initial framing, and then we come and we talk about UFOs. What are UFOs out there? And so one of the most famous fallacies for UFOs is the so-called appeal to ignorance, which is a terrible name because it just confuses my students to know pieces to understand what this means. So absence of evidence is not really helpful if you're trying to make a case, right? And so I say the ignorance is we all have a lack of information, but I have to emphasize this over and over again, but they do finally get it. And they finally start reporting that in their reports to me, and they really understand how to use this fallacy. But it's one that you really have to talk multiple times about. But I tell them at the end of all this, Dr. Hall totally believes in visitors from outer space. I do, and I'm worried about them. I just don't think they have pilots. Right? So we talk about this beautiful picture over the Grand Tetons in 1972, where something the size of a battleship skipped off our atmosphere and went back out in outer space. And moreover, how about this in Russia in 2013? Everybody had a dash cam for some reason in Russia. So you can see this thing came in brighter than the sun by a factor of 10 for a few seconds there. 44 kilotons explosion in the upper atmosphere. Just an astonishing incoming, UFO. And here's some physics is fun on this one. They saw this thing light up the sky. They went outside. They're looking at this bizarre cloud structure that was left up there, and then watch what happens. I'm not sure what he's saying, but I can imagine what he's saying. So that's interesting, right? The light beat the sound by at least a minute. And that's how a lot of people got hurt. They went to the window, they're looking up at that thing, and then the window shattered. Nobody got killed, luckily, but a lot of people got cut by glass because of that. So physics, you can always put some physics in there, get people excited about that. We have this amazing, aerial, one of our satellites happened to catch it. We really know, matter of fact, we were able to calculate the orbit of this thing, right? Pretty amazing science on that. So you're wondering, that's almost like a city killer. If it came in at a slightly different angle, that could have really hurt some folks. So what are we doing about it? Well, also we know that other planets in the solar system impact it all the time, right? So, all the time. In my lifetime, which seems like geologically speaking, all the time. Nobody thought this was gonna happen. We saw that comet going to, so we have, sadly we didn't start until 1995, but we've been finding near Earth asteroids. And We are finding a lot. Here's the latest count. The tally is up to 864 asteroids that orbit within Earth's orbit that are larger than a kilometer across. Pretty astonishing, right? As a matter of fact, here's a nice little image of our crowded neighborhood. Just keep in mind, though, that blue circle, the size of that blue circle is the orbit of the moon. But nonetheless, the solar system is not quite the place we learned about it when Pluto was still a planet, right? It's much more active, much more exciting than that. And so this, of course, a worst case scenario. Famously, the science fiction writer Larry Niven asked rhetorically, why did the dinosaurs go extinct? It's because they didn't have a sufficiently developed space program, right? And so we now have something along those lines. Matter of fact, here is the DART mission from 2 or 3 years ago, where we actually put a projectile and moved perturbed the orbit of this little self-orbiting pair of small asteroids. So yeah, and here's the evidence that it worked, right? So we can move an asteroid. Well, we probably could, right? So this is the science. Also, the search for extraterrestrial intelligence is the actual search for aliens. But before I go there, just I always like to kind of give a piece of something tangible. And so what I'm going to pass around here is a little chunk of that Chingabinsk meteorite. This was in outer space 12 years ago. This is a literal piece of that thing that descended down, and you can hold a piece of outer space, recent acquisition, orbiting the sun on its own for 3 billion years until it happened to cross our paths, right? So just trying to keep the excitement going on that. So cryptozoology, ESP, psychokinesis, these kind of things are interesting. Again, I always like to, if I take something away, and it feels like I am sometimes, people look a little crestfallen when they find out there's not a lot of evidence for the Loch Ness Monster. Especially some sympathy for the Loch Ness Monster for some reason. Bigfoot a little bit, things like that. You take something away, I'd like to give something back. So here we talk about near-Earth asteroids, not exactly a great gift, right? But something we should be worried about. SETI, well, yeah, we are looking for them. ESP, the sixth sense. Well, there are some sixth senses, right? I love the proprioception is kind of a sixth sense, isn't it? I don't know. How about echolocation and all the different senses animals have that we don't have? Very interesting things to talk about. I mean, in Oliver Sacks' Mad Mystic, the disembodied lady where she completely lost her proprioception ability. And students forgot about learning about this if they ever did. Like, can you close your eyes and make your fingers touch? That's about as good as I can get, but it's not bad, right? To remind them. And then, we can talk about animals and how they sense the world and how it's very different from ours. So there's all these different avenues to go down to kind of replace it. How about cryptozoology? Well, you got like the coelacanth. Remember this, the dino fish? There's a great book about that. Deep sea vents, things like that. So this was actually a lovely book called A Fish Caught in Time, where they discovered this fish and they couldn't find it for 30 more years until they're still alive and still living in the deep sea. So wonderful stuff like that. So let me just share with you something I show the students towards the end of the semester. And this is just a little excerpt from James Randi's wonderful Secrets of the Psychics. Do you guys know this video? It's a little old, but it's really got some great stuff in it. Hang on, I don't know what happened just there. So let's see. My video's not playing. I hate when that happens. Any ideas? Well, thank you. That'll do it.
Maybe.
5 being the most accurate. How many gave it a 1? Let's see a show of hands. 2, 3,
That guy's counting on his hand for some reason.
4, and 5. Okay, so we scored pretty highly with this. Let's do a little experiment. We've got your horoscopes right in front of you. Take them in your hand like this and hand them over your shoulder to the person behind you. Okay, everybody, and the guy at the end down there, you'll have to come up to the front, because these people in the front don't have one now. Okay? Everybody change around. Everybody's got to open up somebody else's horoscope and read it carefully, please. They had all received the same horoscope. The personality descriptions were generally true of everyone, like recently you have had to recover from a disappointment. Some of them seemed specific because they were so personal. Your sexual adjustment has presented some problems for you. And there were others that anyone might hope would be true. You have a great deal of unused capacity. People like to believe.
So that's when I show that to the students, I was a little apprehensive because it was part of another aspect where I was using astrology as the whipping post of what is not science, as a lot of philosophers of science do. But then they loved it. They ate it up. They loved seeing somebody else subjected to the thing I did to them on the first day. Now, if any of you psychologists can explain to me why that is so entrancing for them, I'm not sure, but they love it. And so I always end kind of towards the end of the semester showing them that little clip. My main point too was that as you develop along these, you get more sophistication. To talk about homeopathy and chiropractic, we really need to talk about the scientific methodologies, a little bit about research, a little bit about publications, peer review, and things like that. So I put them at the very end of the semester, and it is pretty successful to talk about those at that point. Creation and evolution, I leave that for last. We're kind of a red spot in a blue state in Fresno, in California, and if you start talking about creationism or things like that early on, people just kind of close their book and put their head down, and they don't want to engage. So my strategy is to first talk about the age of the Earth. It's an amazing story. I have the physics background to talk about it. We talk about radioactive dating, what that really is. It's not just carbon-14, of course. All the different things that go into understanding that our Earth is of great antiquity. And they seem to enjoy this. We talk about, of course, dinosaurs, the extinction event with a meteor. And then what I really love is Eugenie Scott's, and I'm not sure, do you ever use this strategy? I'm talking to Dr. Honey. So she has this thing called the creation evolution continuum, and you can outline this thing and ask students, well, it's not black or white. I mean, you're a creationist. Well, what kind of creationist are you? Are you a flat earther, which I never would have thought somebody would say yes to 20 years ago, but maybe they will now. There's folks that are geocentrists, believe the Earth doesn't spin on an axis. Young Earth creationists, and that's kind of where we're talking answers in Genesis. But you got the old Earth creationists, different takes on that. You got the intelligent design creationists that agree that there are some common ancestry, and then you've got different interpretations that still incorporate some level of spirituality, but evolution is still true, and that would be like your Ken Miller, right, who's a devout Catholic, but is maybe one of the most well-read or biggest authorities on evolution. So I show them this map, and it's instead of being a binary option, they have to kind of think about this continuum and why they're on it. And this is from Eugenie Scott. It's phenomenal. It's available on the webpage of the National Council for Science Education. So one final thing I do is I talk about deep time, and this is kind of this idea of consilience, that if you reject geology, or if you just, or if you reject evolution, really kind of rejecting the whole package. Science kind of is really stitched together in a really intricate way. And I think by the end of the semester, I have them kind of buying into this consilience and all these different threads that come together. I like to tell them about, many of them have an opportunity to go to Los Angeles and go to the La Brea Tar Pits. Anybody been to the La Brea Tar Pits? Fantastic. And in that place, they have this giant mural. It's at least 15 feet high, and it's kind of exactly that, the deep time depicted in one big mural. And I love how they have basically an astronaut stepping off into space. Can't tell if it's male or female. I like that too, because they're in a spacesuit. But yet the big toe of the human is all the existence on that entire ribbon. And I always like to leave this image with them as a last thought for the semester. And I'll leave that with the last thought on my course. Thank you very much.